Hello everyone and welcome to another video in this series about the basics of C# programming with Unity. Today we are going to talk about enumeration type, also known as enum. First of all, what is an enum? An enum in C# allows you to define a set of named constants. So it's a list of values that don't change and that have a name. To declare an enumeration, we start by writing the keyword enum, followed by a name, in this case enemy type, and a pair of curly braces. Between these curly braces, we can then add our values, for example, boss, elite, and standard. So we've just created an enumeration type that can have three possible values. In the previous episode, in the section on switches, we used an enemy type variable which contained the type of enemy the player was fighting in the form of a string. Using strings here is not recommended. There is a risk of typing errors that could break our code. For example, if in the enemy type variable, instead of writing boss with an uppercase b, we write boss with a lowercase b. In this situation, this value is no longer taken into account by a switch case and we therefore trigger the default case. To fix this, we can use an enum instead. We change the type of the variable to enemy type, and in this case we can assign to it one of the values defined in the enum. We write the type of the enum, so enemy type, then a dot, and finally the value we are interested in, for example, boss. You can then change the switch to replace the strings with the enum values. So enemy type.boss, enemy type.elite, and enemy type.standard. Enums also make your code more readable. Let's take another example. You have several difficulty levels in your game, easy, normal, and hard. And you have a variable of type int that contains a number depending on the difficulty level. For example, int difficulty equal 1. When you read this code, you might wonder what this one stands for. Is it the easiest level of difficulty? Or is it the hardest? Do you start counting from 1 or from 0? In short, it is not very clear, it's full of questions, and so it's not recommended. Instead, you could declare an enum like this. So we declare our difficulty level enum with the three difficulty levels, easy, normal, and hard. Then we can have our difficulty variable declared like this, and give it the value difficulty level.easy. This time it's much clearer, there are no more questions, the difficulty level is set to easy. By default, each value to our enum corresponds to an int. The first element has the value 0, the next the value 1, then 2, 3, 4, etc. You can change the default value if you need to, by specifying the corresponding numeric value for each value in the enum. You can also change the underlying type to another integral numeric type, such as byte, short, or long. You can retrieve the numeric value by doing a cast, like this for example. Long value equal long in parentheses to perform the cast, and the value contained in the difficulty variable. Here, in value, the value selected in difficulty will be represented in the form of a long. You can also cast the numerical value to the enum as follows. We have our difficulty variable, and here we are going to assign it a value cast to the difficulty level type, so the type of our enum, with the numerical value 2. Let's take another example. You have events in your game that happen on certain days of the week, for example, every Friday. You can therefore declare a days enum, which contains the value of the different days of the week, and the frequency variable, which contains the value of Friday. So your event must occur every Friday. But let's imagine you have an event that has to happen twice a week, or even every day of the week. At the moment, in our frequency variable, we can only select one value from those proposed in our enum, so we can't select several different days. Luckily for us, we can add the flags attributes to our enum. So we write flags in square brackets just above the line where we've declared our enum. This attribute allows you to select several values in the enum. In order to be able to select several values, we also need to assign specific values to the members of the enum, specifically powers of 2. So 1, 2, 4, 8, etc. If you look closely at the binary representation of these numbers, we can see that only one bit is set to 1 for each number. This indicates which value is selected. As soon as the bit has the value 1, the corresponding value is considered to be selected. If you only want to select Monday, you can represent it in this way. If you want to select Saturday and Sunday, you can represent it in this way. with a 1 corresponding to Saturday and Sunday. And if you want to select all the days of the week, then you put a 1 for each day of the week. Another way of writing values would be to use this notation. A 1 followed by 2 less than signs, then a number, 1, 2, 3, etc. For example, this operation means that we take the number 1 in its binary form, and we shift all the bits to the left 3 times, then we complete with zeros. So here we obtain the value 8. If you have a lot of values in your enum, it becomes easier to read and avoids typing error with large numbers. For example, for the 30th value, if you take a 1 shift 30 times to the left, it's still easier to read than this large number. To assign several values to a frequency variable, we can use the OR operator. For example, here in frequency we can select Monday and Thursday by putting an OR between Monday and Thursday. And finally, if we want to test whether frequency contains the day Wednesday, we can use the AND operator in this way. So here we declare a boolean is Wednesday, and its value will be a logical AND between frequency and the day Wednesday. And if the result of this AND is equal to Wednesday, then this means that Wednesday is selected in frequency. You can also use the hasFlag method, which is used like this. Frequency.hasFlag, and between parentheses you pass the value you want to check. So here is Wednesday selected in frequency. Let's test it out in Unity. Create a script and call it enums. Open it in Visual Studio. Let's imagine that your player can equip different types of weapon. Let's start by declaring an enum containing these different types. We'll add the sword, axe, bow, staff, and dagger types. Now declare a variable of type weapon type and give it the value weaponType.sword. We are now going to display a message in the console depending on the type of weapon equipped. To do this, we are going to make a switch on the weapon type value. To add the different cases, in Visual Studio you can right-click on the switch keyword, then Quick Actions and Refactorings, and finally click on Add Missing Cases. This will automatically add all the possible cases corresponding to the various possible values in the enum. You can do the same thing to add the default case by clicking on Add Default Case. For each case, we'll do a debug.log to display a message in the console. So the player attacks with a sword, the player attacks with an axe, a bow, a staff, and a dagger. Let's go back to Unity to test. If you still have the game object from the previous episode, you can delete or deactivate it. Let's create a new game object and add our script to it using drag and drop. Then click play. The console shows the player attacking with the sword. And if we replace the current weapon with a staff and test again, we can see that the player attacks with a staff. We are now going to test enums with the flags attribute. We'll start by creating an enum, damage type, to which we'll add the flags attribute. This attribute is found in the system namespace. So we can either write system dot in front of flags, or add the line using system to the top of our file. We'll then declare a damage type variable, and for the moment we'll give it the value damageType.fire. We'll then make a switch on this variable and display a message in the console depending on the type of damage. You can test this in Unity, and you can see that the damage type is fire. If we change it to damageType.frost, we get the right message in the console. Now we are going to replace the damage type and add a fire in addition to frost. Our damage is now fire and frost. If we test again in Unity, nothing is displayed in the console. In fact, in our switch, our cases only correspond to the values where only one type will be present, and we have two in our variable. We therefore need to add the other possible cases, if the damage is physical on fire, physical on frost, fire on frost, and finally if the damage is physical, fire and frost. If we test again in Unity, we now have the correct message displayed. And that's it for this video on enumeration in C#. I hope you found it useful. If you have any questions, feel free to ask in the comments. Thanks for watching and see you next time.